Section 1.2 is going to take 2 days. The first day we're going to be talking about order of operations and evaluating expressions. If we look at part A here, the math needed to be known for the lesson today, we're going to substitute values into a variable in order to find the value of an expression. But we're going to begin first by writing out your order of operations so you remember them. Alright, so the order of operations. What mnemonic do we use to remember it? Please excuse my dear Aunt Sally. So please excuse my dear Aunt Sally. The P stands for you do what's in parentheses first, followed by your exponents. And then once those are covered, you're going to then multiply and divide, whatever comes first from left to right. Okay, so you don't always necessarily multiply before you divide. Alright, if the division, as you look at it from left to right, occurs first, that's what you do. And the same thing for addition and subtraction. Do whatever comes first as you look at it from left to right. Alright, so let's go ahead and solve this this expression, or evaluate it. So what we want to do is plug in -3 for A and plug in 5 for B. So we're going to have 2. Actually, let me rewrite this on a clean board. Okay, so here I rewrote it and I plugged in -3 for A and I plugged in 5 for B. Now notice, super important, that when I plug a negative number in for a variable, I make sure I put that in parentheses. So notice that my -3 is in parentheses. Okay, now please excuse my dear Aunt Sally. So we want to do what's in parentheses first. Alright, so I look here and I have -3 times 5 written inside parentheses. Right, so what's that going to give us? -3 times 5 gives us a -15 cubed minus 3 times -3. Alright, so -3 is just in parentheses. It's not being multiplied, divided, added, or subtracted anything, so we're just going to leave it. And then plus 5 times 5. Okay, next, the exponents. So I look here. I have -15 cubed. So 2 times -15 cubed, if we plug that into the calculator. Make sure the -15 is in parentheses before you raise it to the third power in your calculator. And when you do that, you're going to get -3,375 minus 3 times -3 plus 5 times 5. Okay, now I'm going to look to multiply or divide, whatever one comes first, as I look at this from left to right. There's no division, there's just multiplication. So I have -3,375. I'm going to multiply that by 2, and I get -6,750. Alright, I have now a -3 times a -3. That's going to give us a +9. And then I have a +5 times 5. That gives us a +25. Alright, so when you add them all up, you're going to get -6,716 as your answer. Alright, part B, our word problem of the day. Every weekend, Morgan buys interesting clothes at her local thrift store and then resells them on an auction website. If she brings $150 and spends S, write an expression for how much change she has. Make a table. that shows the amount of money remaining for S equaling $27.13 and S equaling $55.14. Alright, so if you remember our three-step process here for writing expressions, remember that the first one is to look for keywords that would indicate some sort of mathematical operation that we're going to be using. Alright, so I look and I see the word spends. Right, so she brings $150 to the thrift store, but she spends S. How much change will she have? Okay, so the spends would indicate there is subtraction taking place here in this problem. So we're going to put a subtraction sign above that. Alright, we then want to define our variable. This is easy because it defines it for us. S is equal to the amount of money spent. Okay, so our expression is going to be 150 spends, so minus S. Now, we're going to use the table to show the amount of money remaining, or the change that she has if she spends $27.13 and $55.14. So we're going to plug those two values in for S. So 150 minus $27.13, $27.13. So $122.87 for the first one there, and then 150 minus $55.14. That gives us $94.86. All right. Now, how much money would Morgan have spent if her change was $37.12? Alright, so here we're going to have to set up an equation. So here was our expression. Our expression doesn't have an equal sign. We're going to need an equation for this second one. So we know that 150 minus S, what did that equal? That equaled the amount of change. So we could say that C equals amount of change. So notice now I've set up an equation. I don't know what S is. That's what we're trying to find. But I do know that the change was $37.12. So I'm going to plug in 37.12 for C. And now I'm going to solve for X. This becomes an equation. This will be a two-step. I want to get S by itself. I want it to be positive. Alright, so you kind of see here that S is negative there. I want it to be positive, so I'm going to add S to both sides. So that gives me 150 equaling 37.15 plus S. You cannot combine like terms because 37.15 doesn't have a variable S with it. Alright, got to get this by itself now, so I'm going to subtract $37.15 from both sides. And 150 minus 37.15, that gives me 112.85. So $112.85 is the amount of money that Morgan ended up spending. Alright, for the second one. A biker is traveling at a speed of 15 feet per second. Write an expression for the distance the rider has traveled after s seconds. Make a table that records the distance for 3, 5.8, 11.1, and 14 seconds. Alright, our three-step process. First is to look for keywords that would indicate some sort of mathematical operation. So I see 15 feet per second. So this per is going to indicate multiplication taking place. Now, I got to define my variable. It's easy because it's already defined for us. So s is seconds. So s equals the number of seconds. Alright, so my expression becomes then 15 times, or 15 feet per, or 15 times s. Alright, so 3 seconds, 5.8, 11.1, and 14. I'm plugging these in for s. And this is going to give me distance traveled. So 15 times 3, that's going to give me 45 feet. 15 times 5.8, it's 87. 15 times 11.1, that's 166.5. And 15 times 14, it's 210 feet. Okay, so here was, there's my expression, filled in the table. Alright, now, how long would it take the bike rider to travel a distance of 135 feet? So again, for this, I'm going to have to write an equation. So 15s. Alright, what did the 15 times s, or what did that end up giving us when we plugged in the different seconds in for s? It gave us distance traveled. So we're going to say d equals distance. Alright. We don't know s, but we do know d, so we're going to plug it in. So we're going to use a different color. So 15s equals 135. And so I'm going to now divide by both sides by 15 to get s by itself. So 135 divided by 15, that equals 9. So in 9 seconds, the bike rider would travel 135 feet. Okay, now part B, it's tricky, and you just gotta think logically about this. So what would the expression, alright, so we want an expression, not an equation. So what would be the expression for a second bike rider that traveled at the same rate but started 20 feet in front of the original rider? What about 30 feet behind the original rider? So we know that the original rider this is the equation that we used to figure out how long the original rider would take to go 135 feet. Now, we want to find out how long it would take the second bike rider to go that 135 feet. However, they start 20 feet in front. So let's write the equation, and then we'll convert it and write it as an expression. So we're going to have the 15s. Now the second rider starts 20 feet in front, so plus 20 equals 135. Alright, so actually what I think they're just looking for is, we don't have to put the 135, they're just looking for the expression, so the 15s plus 20. Alright, and then for the 30 feet behind, that's just going to be the 15s minus 30. Alright, so those are the expressions. Okay, so we will, that's all we're going to do for the guided note video portion of day 1 of 1.2.